All right, we should start. Well, thank you everyone for attending this afternoon, this morning, this evening, wherever you are in the world today. I am joined with Jeff Smith, which I think pretty much everyone knows and follows on the Twitterverse or the blogs. I am Brian Spinley. I'm another product manager in the Oracle database tools team. And today we are here to discuss the question or the topic that comes up multiple times that no one ever wants to discuss, which is continuous integration and continuous development for Oracle databases and Apex developers, and the myth or legend or fallacies or truths behind it. Does it actually exist? Can I actually do it? And how to do it if it does exist. Now, first, I think we should start off by explaining what CI/CD is, because it kind of gets thrown around a lot, but there's not a lot of why or what with it. So CI/CD is just continuous integration, continuous delivery, or continuous deployment. That CD is iffy depending on who you're talking to or what you're trying to do. And what this is going to help you do is it's going to help you add automation into the various stages of the development lifecycle. So if you're developing an application or working with something, a database, Apex, what have you, this will help you automate some of the processes in there. It's going to help consolidate your code. It's going to help your developers be on the same page. And it's going to automatically have this code merged and tested and put into this big repository. Now, it's mainly more about the why. So why are we even doing this? Why do we even care? And the why about this is very important because it does introduce consistency into your development process. And that's important. You want to have consistent processes in place so that everyone's on the same page and you don't have what they call the cowboy coders or whatnot, the people that are just randomly coding stuff, not paying attention to the guidelines that you had set forth and just doing what they want to do. It's going to cause issues. It's going to cause problems. It also brings in the accountability / the security. We need to know that code that basically is creating a user in the database called Oracle with password Oracle 123 is not happening. We have to know that that the coding standards set forth for security are in place and tested so that we can prevent these issues from happening. Again, the one that was, I think, in the it's getting even deeper was the SolarWinds when it was in the news yesterday for another reason. And we know part of that was because they had bad passwords and bad procedures and they blamed it on an intern, unfortunately, which is sketchy, but still, there was an issue there. And this process is going to help you with that because as you go through the merge process, and we'll see this, you'll see what code actually is being put into your main line and you'll be able to understand it. Another thing is with this process is you're going to find issues, you're going to find quality issues a lot faster. Because every time that a certain event happens, whether it's going to be a push or a commit to the main line, and we'll talk about some of these terms in a minute, it's going to spawn a process that's actually going to test the code that particular developer did on an instance, on an Oracle database, and install what it needs to install, and then report back what happened. We do this at various stages of this development lifecycle now, and we're actually able to do it on clones of our production environment. And again, we'll talk about that in a minute. And then, so when we go to these processes, when we put into dev, when we put in the UAT, when we deploy to production, there are a lot less surprises because we've done it so many times as we develop. Again, it's not the developer that has to do this. It's a completely automated way for doing this so that we can see if there are any issues. And once all this starts, you'll be able to do more frequent releases because they're of better quality, they're standard, they're security, they're secure, as well as they are consistent. So what has traditionally been the issue with DevOps and the database, or CI/CD and the database? So it's been kind of difficult because, and we'll, we could talk about this. It's okay. We can, all topics are here. A lot of the times we all develop with Apex in the database. We're all sitting in a single instance. And yes, sometimes we're going to step all over each other. And sometimes we're going to, I'm working on a package and Jeff is working on the same package and we don't know. And he compiles it one day and I come in and compile mine right after that. And I've pretty much erased all of his changes, and it happens. And the other thing is, it's not always easy to create multiple Oracle databases. There are licensing involved sometimes. There are costs involved. Do we have the hardware? Do we not have the hardware? Do we have the ability to clone? Do we have the space on our array? There are a lot of issues that come with this, and it's not always, a particular developer or coding issue. And the database in the Apex flow is a lot different than the traditional one we see with DevOps, and it's mainly because it's a stateful versus stateless process. If I'm just compiling a bunch of JavaScript files or jars or whatnot, that's really easy to do. I bring up my Docker containers, I compile it, I push it out, and I'm done. Where Apex is mainly metadata driven, and the database has these versions and lack thereof, I should say. We'll talk about EBR a little bit, but again, it's not always easy to version in Apex, and it's not always easy to version in the database. Rolling back, or do we roll forward? What do we do if there's an issue, and how do we get around that? And a lot of times what we have today is we have these very manual processes out there. The change tracking isn't really there. It's kept in a bunch of scripts, or it's kept in a bunch of zip files on someone's laptop, and when it's time to deploy, we pass the zip file around an email. And then somebody jumps onto the development and UAT and production instances and runs the scripts and hopes that it works. So there's a lot of issues around this that we've been facing. So it hasn't really been a very popular option within the database and Apex realm. So what it comes down to is can we fix this? And we can fix this, and we can help you out. And so what we're going to talk about today is we're going to show you some of the tools and processes that we have with the database tools and mainly the database development tools to help with this process, and then reiterate our commitment to this particular area from our team. Jeff and I are wholly invested in this. A lot of this spawned from the COVID project that we started a year ago. It's actually a year and a couple weeks ago when I was on. I was sitting, it was later at night, and I got this email or I think maybe a phone call or something from Joel Coleman. And he's like, can you get on a Zoom call? And it was really late at night. And I'm like, sure. So I jumped on the Zoom call, and they're like, yeah, we need you to bring up, 2 Exadata cloud services and data guard and all this for some COVID project that we're doing. And so we had to scramble, and it was a crazy time to do this. I think we all of us were up for about 72 hours straight, getting these environments up and running and the Apex stuff installed and ready to go. Chris Rice, our manager, was there as well. He was getting all the mid-tier stuff, the ORD stuff and the mid-tier up and running, our authentication stuff running. But then the Apex development started, and they realized that they needed a CI/CD process, because now we had this app that needed to be secure, that needed to have the right coding procedures, that needed to be patched on often, because we were building this stuff so fast and everything was moving so fast. So a lot of this stemmed from about a year ago when that all came down, and we needed a better process. We needed better tools to do this internally and externally. So what do you need to start? And we'll talk about starting, but starting is best done slowly or easily. If you have a team, or if you have a team of developers or DBAs that have never done this before, that have never worked with these tools, it's always easier just to start slow. And to start with that is, just get a free account on, a GitHub, or host your own GitHub, or GitLab, or Bitbucket, or Git. There's a bunch of them out there. For what we're going to be using today, we're going to be using GitHub. Next tool we have is SQLcl and Liquibase. We'll talk about that a little bit more in a second. And then lastly is Jenkins for our pipeline and for some of our automation. And if you want to be an overachiever and see some extra credit stuff, VS Code and SQL Developer for deploying and writing your code, UTPL SQL for all of your unit testing. That's going to become very important in our process. Terraform and an OCI account. Obviously we work for Oracle, so a lot of the demos that the stuff that we're going to show you today is in Oracle Cloud Infrastructure in our OCI cloud service, but it could be done easily on premises. Just some of the advantages we have with the Terraform and building of some of the databases we have are a little easier in OCI, and we'll talk about that as well as we move on. As Jeff said in the beginning, for some of you who weren't here, if you do have any questions or something comes up and we need to stop or slow down or something, go ahead and put it in that QA panel in Zoom, and we will get to it. I'll see it. I have it open up on my screen, and Jeff is here to help and add commentary as well. And you can raise your hand like you did, but we'll probably just raise our hand back at you. Jeff, anything to add before we jump in a little bit deeper here?
No, I like the backstory, because for me it was buzzwordy. Oh, I need to get up with this, and I think a lot of it's coming from different angles, but there's a lot of commonality here too.
Yeah, there was a lot of work, and I'll just be surly for a minute. There was a lot of work that a lot of people did in the background to get this done. But as you saw, the people that get credit is my brother. He comes back to Oracle for like a month, and he's like on 15 videos, and he's on calls with the CIOs and the upper level management. And I had the ability to turn his PDB off and basically turn his app off. But no one talks to me. That's fine. I'm not upset or anything for that. That's fine. Yeah, we
do have family counseling services available to all Oracle employees. So
I think we do get free counseling for these type of events. All right. SQLcl and Liquibase. So SQLcl is, if you haven't used it, it's as they say in The Mandalorian, it is the way. It is basically a command line SQL Plus tool that's about 35 megs big, which you can connect to pretty much any database you have without having to download the entire Oracle client. It's great because we have all these great features built into it. There's a lot of ways to connect to a lot of different things. You can connect to autonomous databases. You can connect to on-premise databases. You can connect to cloud databases. You can connect to cloud database using the SQL REST service. There's a bunch of ways to connect to this database. And I said, it's a quick install, it's a quick download, and you're ready to go. And it has a bunch of features in it. And one of the features we have in it is Liquibase. Liquibase is, we do have it. It comes free with SQLcl, so you don't have to pay extra. And everything that we'll talk about here from our tooling standpoint is all free. We don't charge for any of this. And the Liquibase addition into SQLcl is free as well. And Liquibase is going to allow you to have this change tracking for database schema changes as well as your application express apps in there. And we'll see a little bit in that in a minute. And the Liquibase feature enables you to execute all these commands that allow you to do this change tracking and then move them from environment to environment in a manual or automated way. Whether it's scripted or called from a script, that's scripted, either scripted or called from Terraform or called from a pipe, SQLcl is there and able to run all these things to have that change management and change tracking across multiple environments. And we'll see that in a minute. Anything to add on this, Jeff, for SQLcl?
It's more than just getting Liquibase. We've extended the support for Oracle in Liquibase to cover things like Apex apps, which I'm sure you'll show us in a bit.
Yeah, and one of the great things about SQLcl is we keep it up to date frequently, and we're pushing out a lot of updates. I think how many times a year are we doing it? 4 or 5 times a year, maybe even more. And
quarterly, yep.
Quarterly. And the 20.4 release, I think, also has the JDBC drivers for database 21. So if you are working with 21C at all, this has the drivers for it and everything. So we do keep it up to date relatively often and whatnot. All right. Okay, so Liquibase and CL. So what can we do with this? So here we have the syntax for doing some of the things that we can do. The first thing is generate object. And we can generate changelogs, as it says here, for Apex app, for ORD's REST service modules, as well as any database object. It's very easy. You do at the SQLcl prompt, You'll do LB, gen object, and then you'll give it the type, whether it's table or what have you, or orgs or Apex, and then you'll give it the name or the application ID, and we'll see that in a minute. And what it's going to do is going to go and pull that out of the database and going to save it off on a file for you. Or you can generate all the objects within the schema with LB gen schema, and it's going to go through and it's going to grab everything within the schema you're working in. And that's mainly what we're going to be working with today. Then once we have that and we have that environment set and we have it all there, we can move this from environment to environment with Liquibase update. And then you do this changelog and controller, or you can update individual objects, as well as you can pull individual objects. And then lastly, we can also do rollbacks depending on what we're doing and where we are. So we can roll these backs. And we'll talk about rollback in a little, probably at the end of this, because rolling back is an interesting thing these days, and it depends on what you're doing and where you are and how you want to do it. Again, we can't promise a world with rollback, no one can, but we do have some suggestions and some ideas to help you with issues if you have them. So we'll get to that in a little bit. So what we can do is, let's take a look at Liquibase in action here. So this right here is, we're just going to log in with SQLcl. And I'm going to log into this database. This is an autonomous database. It's a 21C database. And we're going to connect as dev3 as the user. I'm going to give the password here. And then we're going to actually start looking at pulling the objects that are out of here. So what I'm going to do in this environment is, first I'm going to create a table. It's a very simple table. And then we're going to put some data in this table. Three rows. Now we have 3 rows. We'll just do a quick select from the table. We'll do a select star from emp, because that's always what we do. And we'll see that there is data in this table. So now what we're going to do is we're going to just add some procedures. So we just have a little bit more than a single table in our schema. And now we're going to run our Liquibase gen schema. And what it's going to do is it's going to generate a set of 3 files, one for the table, one for the first procedure, and one for the second procedure. So we'll have these 3 files. Here it's going to go. It's going to run through, and you can see all the stuff that it's looking to get: directories, clusters, tables, views, all sorts of good stuff, indexes. It's going to get it, and now we have it. And what I'm going to do here is, let me just show you really quick. We'll see that we have the controller XML, which basically is a list of all the files. We have 2 folders, a procedure folder and a table folder. In the table folder directory, we have obviously the table, and then in the procedure, we have the 2 procedures. Now, if you've used Liquibase before from SQLcl, what you'll notice here is that if you use the -split now, and this is since SQLcl 20.4, we're actually creating folders for you for the individual objects. Before, we kind of just put them all in a single directory, and that wasn't the best way to do this. Now what we can do is we can basically put the objects in the specified directory. So all the tables are going to go in the table folder, all the procedures are going to go in the procedure folder, and it makes it really, really nice and tidy, especially if we start using our GitHub repository, which is going to be our next step here. So let me make sure I have the same video here. I don't want to do 2 videos at the same time. Yep. Okay.
So Brian,
yes.
Did we talk about what a changelog is? How it's sort of an RPM for our schema?
We're at the changelog start right now. Would you like to talk about changelogs?
So we talk about Liquibase, and I don't want to assume everyone knows what Liquibase is, but it's basically allowing you to bring change management versioning to your living, breathing schema. And so when Brian's in there saying, go generate these files for me, SQLcl is interrogating the database, pulling out the objects, parsing those objects, looking for dependencies, and it's ordering those files in that controller such that we can now use that payload to go put onto another system that already has a version of this running, or it hasn't been installed yet, and it can be deployed. And one of the benefits of those individual files is obviously you can put those into a source control system like Git. But this is one way of using it. So when Brian was saying, you might step into this tiptoe, or you might dive in all at once, obviously people have been building Oracle applications and versioning them for years. So a lot of times people have hand built their own installer scripts, their own upgrade scripts. You might have written code that writes the code for you, and using it as we're showing it right here, you can come in and have nothing built, nothing available to take care of this stuff, and it can do a lot, if not all of this, just for you out of the box. But these changelogs could also be SQLcl or SQL Plus style scripts that you've already written that you could add yourself and just use SQLcl and the Liquibase stuff as a harness to deploy these changes. But a lot of the work we put into this code handles so much of the work for you, especially like the object ordering. You know, you've got types and you've got views and indexes and tables that have to be put down in a specific order, not to mention the Apex stuff. And we also handle 100% of what you can do in an Oracle schema. So all the different data types are supported, all the funky things like materialized view logs or, I don't know, advanced queuing objects. It's all going to be supported. Sorry, Brian, I didn't mean to interject for so long.
That's an important point, is the dependencies. So we do have a way, and there's a slide on this, to basically roll your own. But if you roll your own, then you have to make sure you have your dependencies correct and in the correct order, because if you're compiling something where a table doesn't exist because you had the wrong order, it's going to go invalid. So it is important to know that SQLcl and Liquibase will actually get those dependencies in the right order for you when you do it. Now, which brings us to our changelog table, which every time we move this to an environment, we're going to have this changelog table in there. And you could see two examples of what's in that changelog table here. So we have a changelog details, which is a view that sits on top of these two tables that are in there. It kind of gives you a nice, view, there's a lack of a word, to see what actually happened. So you see the file name that was used, and then it's going to show you the SQL that was actually run. And obviously this helps with rollback because we can just, we can actually see what's on here and we can pull it back, or we can go and grab the old stuff and reapply it. But you can see here that in the first one, in the red box, this was applied on a schema that already had the emp table. So though the emp table, that XML file has the full table create in there, Liquibase saw that the table existed, said, oh, you're missing this column, and it issued an alter table, add the column to it, instead of deleting the table, which would be bad, and recompiling the entire table. So it's smart enough to know, hey, this stuff exists, I'm going to do this rather than that. The second one is, a little bit what we were actually doing. We can see here that when we applied that to another instance, it's going to basically pull out the PL/SQL for that package, run that PL/SQL package, and put it into that new schema. Or as we go up chain from UAT to, or dev UAT to production, it's going to apply the new SQL or the new PL/SQL into those databases as we go on that train, or the happy path, as some people call it, to production. So this is really good, and it will help you with the dependencies, as well as knowing what to do and where. So if we want to see an example of this, what we have here is, again, we'll jump back into our environment, and we're going to jump again using SQLcl, and we're going to jump back into our environment. And what we're going to do here is we're going to work a little bit with how the code is going to go, and we're going to start looking at what we want to do with applying this, as well as working with Git. So again, we're going to jump into here. We're going to use dev4 now. And what we're going to do is we're going to issue an update. And this is actually going to take what we pulled from that user, that dev3 user, and we're going to put it into a new database using this dev4. And we're going to see here that it's going to create that table for us. So here it is, it's running, it's going to create the table. It's good, then it's going to apply those two PL/SQL packages into this new environment. And there we go, the PL/SQL packages are in there, and we're done. We've now just moved all the objects from that schema to this new schema. And then here we are quickly in our SQL worksheet that we have in the Autonomous Cloud, or that you can have with by installing orgs and using this new tool we have, which is the web-based SQL worksheet. And in here, we'll just look at this particular table. And just as we saw in that GIF, when we put it into this new environment, we had these three files put in there, and there's the file path. And then here is the actual SQL that it ran for each item. So here's our emp table, and then we have the two PL/SQL procedures that were put in this new schema. Now, granted, this is a very simple, more scaled down example, but you can see that generating that schema and then moving it from environment to environment is very easy with SQLcl and Liquibase by pulling those objects down. Okay, so now that we have these we know how to use Liquibase, we know how to pull all the objects out, we know how to apply them. Now we need to start talking about how do we get this into a CI/CD process that's going to work for us, that's going to work for a database developer or an Apex developer. And this brings us to SQLcl, Liquibase, and Application Express. All right, so Liquibase will generate the objects for Application Express, and there are two ways to do it. First, we can do that gen object, as we said, the type, and then the application ID. And what it's going to do, it's going to create a single file, just as you may do from Apex export. And we're going to have this single file that we can use and go from environment to environment. If we want to move and split this up into multiple files so we can actually see the changes that developers are making, we add just that dash split. We also want to do the skip export date and export the original IDs. We're doing this because if we don't add these, the exports are going to have new IDs and they're going to have dates. And when we try to merge that into our Git repository, those are going to show up as changes. And then if this is a huge app, it's got hundreds of pages, there's 100 merges now. Someone's going to have to dig through and look and say, oh, well, this is just the date, or this is just the ID changing. It's not an issue. It's fine. There's no actual change in the page. So if we do it this way and we pull them out like this, we're now able to see just the changes from page to page to page, or if there's a shared component or an object or something that somebody changed, we can now see those individual pieces when we export that app. Now, we're going to get a little bit more into the process of having pull requests and branches and whatnot. But when you are working with your application and you do this export with Liquibase, and you're going to push those changes into your Git repository, Liquibase is smart enough to say, oh, this didn't change, this didn't change, this did change, and those are the files that are going to be updated. So when you actually do that push into the Git repository, only the files that have been changed, or those pages, or that's your shared components or what have you from Apex, will reflect that change. So we can actually see what the developer is working on. And when we go to that code review, when we go to that merging back into our main code line, we'll know exactly what was changed. Again, going back to that accountability, going back to that security, going back to that standardization. We can now see it in use through this. Then when we want to put this application into our new environments, again, just as we saw, we did the Liquibase update changelog controller to get our database objects, we can do this with our Application Express apps as well. And it's the same way. So think of this, we're kind of theoretically building our pipeline here. First thing it's going to do, it's going to get our environment and set up our environment. Next thing it's going to do, it's going to apply the new database objects. And then one of the other things it's going to do after applying the database objects is we're going to install our Application Express app into the environment. So let's see this a little bit at work here. So again, what we're going to do here is we're going to actually go and we're going to push the code that we just pulled out with Liquibase, the database object. So it was the table and the two procedures, and we're going to push it into a Git repository. All right, very easy command, git push. It's going to push it up there. All right, so now we have it in our repository. So here it is. Here's my repository, and then here are my objects. We got the table XML, and again, we can see just the SQL is wrapped in XML. We have our controller files. We have our procedures. Everything is here in our Git repository. All right. Excellent. Got the database objects. Now let's go to Application Express. So here's a very simple app. It's got a page. I can run it, and it's going to have a report on the data that we saw there. Here are the 3 rows that we entered. And then we added some buttons to actually run those procedures, the downgrade button and the upgrade button. The downgrade, it adds $100 to their salary. And then the downgrade button divides their salary by 10, which is not nice. But regardless, that is in there and it's working. So what we're now going to do is we're going to make a directory called Apex within our Git repository, and we're going to pull the app down. So again, we're going to jump into SQLcl. We're going to connect into our autonomous database. And again, this doesn't have to be an autonomous database. It's just easier for us to use the autonomous database because they come up in 2 minutes. And we'll talk about that in a second of what we can use and where. And now we're going to actually run that SQL or that Liquibase command to generate the object. So here we go. We're going to run it now. We've exported it. And now what we're going to do is we see that we have that controller XML for the Apex app, as well as a folder called F101, which has all of our application express items in it. And once we do this commit, you're going to see the page here go crazy because we're adding all these files. There it is. We see all the shared components, the pages and whatnot. It's all in there. Now we're going to push it to our GitHub repository.
Hey, Brian, I've got a question for you when you think you've
Sure.
got it might be interesting to everyone else. Steve on the chat's asking about the Apex artifacts when Liquibase spits those out.
Mm-hmm.
He's asking, what is he saying? Will it only write out the Apex artifacts that have been changed with respect to the current state of XML files in the current directory and subdirectories, or with respect to last export date that Liquibase is tracking in the database? Or maybe you can just talk in general.
Yeah, well, actually, this is actually going to show you what it does. So let me just finish the video here. So now that we have this, we've updated, we have the Apex app in there. We can see it. And we know what's going on with it. There's our application folder, and then we have pages, shared components, and all that stuff in there. Again, it's not the largest app in the world, but it is still an Apex app. And here's a controller, which basically looks very similar to like the install SQL. That's going to just basically run all of our pieces of our Apex app. So now what we're going to do is we're going to actually go change the Apex app. Let's go change this Apex app. Again, not the biggest change. We're going to basically go in there and we're going to change the title of the region, I believe. Not a huge change, but again, this is going to now reflect the change within our environment. So we're changing the title to demo emp report. We're going to save it and run it. And then it changes from demo to demo emp report. And there it is, same report, but our title has changed. So now that page has changed. We jump back in here. We're working with our app. We're in the right directory. We're going to do the same thing and we're going to pull those. We're going to actually do another export. And we've done the export, and now we're going to push those files to Git. And we're going to add them. And what you're going to see here is that the only things that are going to be pulled, or the only thing that has changed, are the stuff that has been reflected as a change from when we pulled that application express app out with Liquibase. And so we're going to mark this with a different commit so we can actually see the changes. So we're going to do it 0.4. And there's a couple changes files in there. And now we're going to push it up and we'll go check it out in our Git repository. So we're going to Git push it. All right, those changes are up there. So now let's actually go and look what changed. Well, we know we changed one page. So we should see this change directly in here. So we're going to go in here. We see that the folder obviously has changed because something has changed inside of it. We see that this folder obviously has changed. When as we get deeper down the rabbit hole here, we'll see that we'll get down to just a very few things. So the create application has changed a little bit because there's a region that's changed. And then mainly it's just the page. All the rest of the pages are fine because nothing was reflected. We didn't change anything. The application IDs, the dates didn't change, just the addition to that page. So now we can get down to the change tracking that we want with our Apex apps to see exactly which pieces were changed within there. So we can get down to that. So now let's get to add this now. Now that we can move the database objects out and version them. We can move the application express applications out and then see how they're versioned and get that accountability. So how do we start tying this together?
Can we just peek real quick into one of these XML files? Someone's asking if you can show maybe behind the cover. Actually, I'm sorry, this is a video.
Yes, let me show you it a little bit at the
We'll get to that.
We'll get back to it.
Simon, thanks.
All right. Now we've seen some of this about people asking about data. Yes, you can actually pull data out with Liquibase. Now, I wouldn't use this for millions of roles. We have this thing called ORDS, and ORDS is great at moving data around, of having this REST-enabled endpoints, and you can just move this data around or import the data, or you can use data pump, what have you. What this is great for is metadata tables. So if I have a table that has a bunch of lookups, maybe a few hundred rows, we can do Liquibase data / object and then the table name or table names, multiple tables, and it's going to pull all that data out as insert statements, and then we're going to do Liquibase update changelog, the data.xml that it creates, and it's going to insert that data into that particular table. So we do and can move data with Liquibase, but as Uncle Ben said in Spider-Man, with great power comes great responsibility. You're not going to do this to huge million, billion row tables. That's just not the way to do it. There are other ways to move that data around, better ways to move that data around. So this is probably best used for metadata type tables or smaller tables. Now, with that said, you may not always need to move the data around. It all depends on what you're doing. And you can also roll your own scripts for moving the data around if it's a small amount. It's going to come back to how you're cloning and setting up these environments for your developers, which we'll talk about soon. So as Jeff mentioned, you can also just roll your own and still use Liquibase, but not use that Liquibase gen schema. So what you do is you do lb gen control file. It's going to spit out that controller.xml file, and then you'll add your files in there. So what this does is it still gives you the ability to use this controller XML across environments, but you are taking the responsibility of putting the file names that you have within this file, within this particular file, so that you're controlling what's happening and when. So you get a little bit more control with this, but you have to just make sure your dependencies are there and you're doing everything. So the great thing about Liquibase is when you're generating that schema is if the developer forgot, you know what, I completely forgot that I added that column to that table, and then they commit their code and it goes and it runs and tests, obviously it's going to fail, or one of the packages isn't going to compile because that developer forgot to actually pull and write their own script for alter table, add column. Well, if I'm going to do the gen schema, it's going to catch that for me. So not that the developer still has to be responsible, but it will kind of catch those things and they need to be less responsible, let's say. They can, Liquibase is going to help them with those changes as they go forward with that. So now let's get into the actual pipe and what we can actually do. And this goes back to Terraform and OCI. Now, every cloud company out there has their Terraform APIs, but we on OCI also have our Terraform APIs. And using the Terraform APIs within our pipeline is going to allow us to use these OCI resources in Oracle Cloud to quickly create environments or quickly create pieces that we need for our pipeline or for our development. So right here, we have a very similar, and this is basically the code you would need in Terraform to create an autonomous database. This is it. It's just a couple line code saying, create me a 1 terabyte database named testDB with some random string, and it's going to be an ATP, an autonomous transaction process instance. And that's pretty much it. That's all you need. You need to put it in a compartment. So you have to have a compartment hosted, but that it is. Quick side note, all the code and everything we're showing here, we're actually putting or in the process or have already put into our Oracle DevTools GitHub repository. So if you need to refer back to it, you want to use it, you want to alter it, you want to play with it, it's all going to be in our GitHub repository. So you can take a look at it over there. Okay, so back to the CLI and Terraform, we can use these to create these VMs or these network security lists and whatnot to create our environment for testing. So this isn't a ploy for the autonomous database or to use what we need to use, but the autonomous database is great because you pay for it by the second. And in a lot of these times when we create these workflows, this database is only going to be up for maybe 30 seconds a minute as you apply the code at machine speed and then do the test that you need to do. And then when we're done, we delete the autonomous database. So that whole process may cost you $1 or $2, depending on your licensing on what you want to do with your autonomous database. But spending that $1 or $2 on testing in this autonomous database that you quickly created, how much is, doing that $2, let's say we catch a major bug by doing this process, how much is that going to save you down the road? So again, we'll talk about databases and environments in a minute, but that's just, one of the ways that we're going to look at it. Okay. So the environment that we have here that we're setting up, that we're looking at, again, this is an OCI, but it doesn't have to be an OCI. You can set up this environment on premises very easily, and we'll show you how to do some of this. This is what we have, this flow. And obviously it starts with the developers. And interesting about developers is where, and Chris had this on his Twitter account a couple of days ago, is that line, and this is more of a philosophical question, but is that line between developers and DBA becoming more fuzzy and fuzzy? Are DBAs becoming developers, or are the developers becoming DBAs? That's something we can discuss more Zen at some other time, but regardless, we have our developers, and they're going to commit their code to the code repository. This code repository is going to trigger via a webhook. It's going to trigger a compute VM with Jenkins. And Jenkins is going to run its pipeline. Jenkins has SQLcl and Git and Terraform already on there, so it can do a bunch of things. And then we're going to orchestrate some of this with Spinnaker, and that's some extra credit stuff we'll talk about in a minute. But being an OCI, we can set this compute VM up to have what we call instance principals. And what it allows this compute VM to is act like a user. And we can say, okay, VM, you can do A, B, and C, but you can't do X, Y, and Z. So the VM can create an autonomous database. The VM can create a compute. It can create a load balancer. It can create networking, or it can't. So when we go and we create this pipeline, that Jenkins is kind of orchestrating with Terraform the environment we want to test our code in. Now, granted, this doesn't have to be an OCI. You can do this with scripts. You can do this on premises, but it's, as we said, with the Terraform, makes it really, really easy to do with setting up this infrastructure as code type of environment. And again, every cloud vendor has Terraform hooks, whether it's AWS, Oracle, Microsoft, what have you. So this can easily be replicated. And Jenkins is open source, Spinnaker is open source, SQLcl is free, Git is Git, and Terraform is Terraform. They're just yum install Terraform, yum install Git. Oh, and by the way, in OCI, you can actually do a yum install SQLcl and yum install ords, and we'll get that latest version of ords and SQLcl out of our yum repository, install it on your VM or database cloud service VM for you automatically. Nice little thing we added in there. Okay, so here's our flow. Now let's put this all together. So we saw all the components that we need for this CI/CD flow. So let's start putting these Lego blocks, these building blocks together here. So what we do is we have the start. We're gonna kind of use this in the agile methodology here because it kind of fits the best with this, but you may have other terminology or other ways to do this. So real quick, I saw that Simon has asked and showed the diff. Liquibase will actually show you a diff between two database schemas. So you actually do Liquibase diff. And I can't remember the exact syntax, but you can do two diffs between two databases. So it does that as well.
And there's one named update SQL that generates what it thinks it needs to apply.
That's right. Thank you, Chris. So you don't have to apply it. You can see what it's going to do before it actually does it as well. It's like a pre-check thing. All right. High level flow here. So we're going to start our sprint, our agile methodology, and developers are going to start on their tickets. These tickets are handed out to the developers here. You work on feature A, you work on feature B, you work on feature B or C. The developers go off and do what they need to do. They check in their code. You always want to do a code review with developers and stakeholders, make sure everything's on the up and up. You're going to merge the code with main. The sprint ends. You're going to create a version, version 2, version 3, version 3.5, and then that version is released into dev, UAT, and prod. So from talking to many customers, from doing this when I was a consultant back in the day, this is kind of the process that a lot of people follow. So let's dig a little bit into this and actually see a little bit deeper into what a developer would actually do. So obviously, if you're starting from scratch, you're going to take a baseline of what you're building to put into Git. So you're going to have your initial schema and all the objects, your initial data model, your initial packages or stubs, as well as your initial Apex app. You're going to commit it, and you're going to call this version 0. All right, now the development cycle starts. Developers are going to pull down the code to their local laptops or local environments and create branches for them. My branch for ticket ABC. And at this point, the developers need to start working in individual developer environments. We'll talk about that in a minute. That's one of the very important things here is if this is going to work, it can't all be working in the same database because you're going to step on each other. There's going to be issues and the change tracking is just completely going to go out the window. You have to have these individual environments, and we'll talk about how to get there in a minute. Okay, so pull the code, start working. Okay, code is done. I'm going to push it into my, or push it up to my branch, and I'm going to start a pull request. Now, depending on what you're using, whether it's Bitbucket, GitHub, GitLab, Git, pull request merges, versions, this, that, they're different terms, but they all in essence do the same thing. But in GitHub, it's a pull request, and a pull request is going to lead to a merge. So I'm going to ask for a pull request. This pull request is going to start a pipeline. This pipeline is going to take the code from that branch. It's going to clone our database. It's going to clone or use a copy of production, UAT, or dev, something that reflects the latest version of main or what's in production. So we can see how this code is actually going to work on our what we have or with the latest version of main. If this pipeline comes back clean, we're going to allow the merge into main. That itself, that merge into main is going to cause a pipeline to run. But once we've merged into main, we'll delete our individual development environment and we'll delete the branch. And now once all developers are done, we're going to create that version in the repository. So this is the flow that we kind of see is working for our developers out there today. It's very simple. Yes, there are some things that we have in here what do we do for patches or one-offs? We'll talk about that in a minute. So if we start putting products on top of this environment, we can start seeing that, the developer code pulling and pushing to branches, that's all going to be in Git. But when we start creating these environments, that's where we're going to start looking at Jenkins and Terraform to do some of these things for us. So we see that, again, we're pushing that, creating that PR, that's going to be Git, but these pipelines are going to be spawned by Jenkins and Terraform, and it's going to help us create these environments. So this kind of somewhat puts the products on top of the individual steps we have here. But again, the steps are the same regardless. And again, you don't have to do follow this exactly, but it is at least a roadmap for you to look at. So let's actually look at this real quick here. So what we're going to do is we're going to check out a branch. So here we go. I've created a new branch. All right. And there it says, just do a git status. I'm on 0123 is my ticket and then my name. I'm going to jump into SQLcl and I'm going to do something. You know what? Okay. My ticket is asked me to add a column to the emp table. Okay. So I'm going to connect into my individual environment. I have the latest copy of it. I've just pulled down the latest code from the Git repository. I've created my branch. All right. So now let's start creating this or start finishing off this ticket. Again, SQLcl has this great thing called tables. You just type tables and I'll show you the tables. We're going to look at emp, make sure that, okay, manager is not there. Well, let me alter the table and I'm going to add the manager column. Okay, I'm going to do this real quick here. Spelled it right, excellent. And there we go, it's altered. Now, as we saw before, we're going to actually, we're going to pull the code. We're going to do Liquibase gen schema, and we're going to pull this code down, okay? And obviously, the only thing that has only changed is in the table code, so Liquibase should see that, and the only thing it's going to update is that, obviously, the controller file, but the emp table is the only change that's going to be reflected here. So, all right, we have this. And then what we're going to do is once we have that local to our environment, the developer is going to push their branch into the Git repository. Okay, so now I'm going to just do a git add and a git push here. So here we go. We're going to git add. We're going to commit the code. We're going to have a nice, a very useful name, emp table alter. Awesome, great description there. Okay, we got the change. Now we're going to push it upstream into the repository. And now that code is in the repository. We're going to jump over to Git real quick, and it's going to say, hey, I see that change. So here we go with Git real quick. It should be. There we go. We'll switch to Git, and then there it is, just popped in. I had just done this push. we can either compare and pull it, or what do we want to do with this? So here we go. We're going to compare and look at the pull request. All right, so here it is in Git. What's changed? Oh, this file has changed. Obviously, I see here that I've added the manager column to this table code. Excellent. Got it. That's real easy. All right, as you know, we've code reviewed it. We're ready to go. We're going to create that pull request. All right, pull request is ready to go. I'm good. I'm ready to go. Let's merge that code into main. That code has now been merged into main. So now we have in our new version, well, we'll go create that version, but version 1, you know, again, of this sprint was updating the emp table and adding this column. Now that we have it, it's been merged. We see that 1 minute ago that file was added. We're going to create this version. We're going to call it version 1.0. And we're going to have the release title and the description. And now we've just published this version, and now it's going to zip everything up and make these artifacts for us that we can use later down the road. And so that, again, simplified, but it shows what a developer would do. You'd pull your code, you'd create that branch, you'd do your work, you'd push it up. You're going to ask for a pull request. Once that pull request is done, that's going to spawn a pipe. And then the developers and your code review it. Once you're good with it, you're going to merge it into main. That'll spawn a pipe. And then we're going to be done with that. All right, easy, not that difficult to do. We see that Liquibase makes it really, really easy. All right, so individual environments. So this is important. So how do I do these individual environments? How do I create these? So an individual environment needs to have the latest version of main, and it also needs to have all the objects, some data, as well as the Application Express apps and workspaces pre-created, seeded for you, ready to use. So how do I do this? Well, there's a lot of ways you can do this. In OCI, we have the autonomous database. We have the OCI CLI, SQLcl SDK. We've actually created an application that you can use as a control plane, in essence, to create these autonomous databases, and then with that, add data pump exports onto them. And then we basically take this, we add the data pump export, we install the Application Express app on top of it, and we're ready to go. And these environments can be given out. You can also just create these with SQL+. You can use the ORDS SQL endpoint, the SQL REST service to just run SQL on it, or you can use Terraform. So what we're going to do here is we're actually going to take all these ways to do it, and we're going to put this in our GitHub repository with examples for each one. So autonomous database clones is really easy. If you're working with the autonomous database, there's the ability to clone that environment directly from the UI using a CLI, using an API, using Terraform. Really easy to do if you're using the autonomous database. If you're in OCI, you're using the database VMs. If you're not using the one with ASM, you can just clone it. There's the ability to clone that database environment. Again, it's going to take a while, and we want these things up as fast as possible. You can also create a new database VM from backup. And again, that could be done via Terraform. It could be done via OCI. It could be done from the UI. If you're using Exadata Cloud Service or an Exadata, you can use sparse cloning. I can sparse clone that database, very quickly create that database clone. You need multi-tenancy for that. Or if you're on 19C, you can create 3 PDBs for free, but Exadata is going to allow you to do that very quickly. If you're on-prem or you're in the cloud, you're just using a database, you can utilize multi-tenancy. Again, with 19C, you can create 3 PDBs without having to pay for multi-tenancy, or if you have multi-tenancy, you can do this. Now, we've exposed PDB lifecycle management via these database APIs via ORDS. So if you have ORDS installed in front of these databases, you can use that as a control plane to create clones or PDBs of the database directly through ORDS through these REST APIs. It's very easy to do. You can also just jump in there and have a script that would run and create pluggable database as clone or whatnot, or use the REST-enabled SQL service that comes with ORDS to create a REST service that creates these pluggable databases for you. So when it comes time to give these environments out, I issue these commands, I create these environments for all the developers who are ready to go. Again, multi-tenancy makes this really, really easy to do. If I don't have multi-tenancy, I'm on 11 still. I'm on 12, I'm running a non-CDB. How do I do this? Well, you can do this with reusable instances. Now, one of the ways you can do this is using a guaranteed restore point or flashback database. So for example, if you are on one of these databases, you apply version 1 of the code. and you take, after that's done, you take a guaranteed restore point of your database. And again, this code is actually we're going to be in our GitHub repository for you to take a look at and actually run the SQL for doing this. We're going to set a guaranteed restore point. Developers are going to do what they need to do on their environment. They're going to push their code. A release is cut. Well, then they're going to flash back the database to that point where we installed version 1. We're going to pull version 2 down from the Git repository, so we have everything, apply version 2 onto the database, and then take another guaranteed restore point. And they're going to work and continue that process. So it's going to, in essence, create a nice little environment for the developers to create and use without having to have a multi-tenancy license or, be stuck, having to work in a single instance. So it'll, again, this database can be in a Docker, this database can be in a VM, it could be anywhere, it could be on the cloud, but it does allow them to flash back the database to get clean versions so they can continue their development in their individual environment. And then you can obviously do an rman dupe, an rman clone from an environment that does involve database links. So just make sure that those are set up correctly. And then obviously you can do data pump. If you just data pump export out that entire schema, you now have that data pump you can use and use DBMS data pump or SQL developer to go and plug that data pump directly into your database. And then when you're done, you can either dump the schema and go grab a new data pump and put it on there. So a bunch of ways you can do this without having a multi-tenancy license. And then obviously, as we have here, Docker virtual machines. And then lastly, you can do ACFS cloning or GDB clone as well to quickly create databases using ACFS snapshots. That gets a little bit more technical and it gets a little bit more in the weeds, but there are easy ways to do this, especially using GDB clone. Using GDB clone is actually I call it a meta link note. It's a Moss note, my Oracle support note on how to do this. So that is
hey Brian, there's a question from someone, no name, about cloning. Does this mean developers working on their branches require clones, so the DDL required for the branch is only in their clone copy? So
yes, you want each developer to have an individual environment to work in. You don't want to be all in the same environment. This will separate the changes to that developer so that when we create those branches, we're not mixing code. The code will be mixed, obviously, when you merge everything into main and test it there, but the individual development environments will allow us not to other people to step on each other's changes, whether it's on the Apex side or the database side. And then those changes are merged. Now, there are some times that developers will need to work on things together. And you can create a separate environment that two developers may be working on a particular feature together with. But for the most part, you want individual environments. And I'm at the top of the hour, so we'll just go a little bit longer here. Okay, so the code pushes in the processes. So every time something happens, you want to spawn this CI/CD pipeline. It's going to clone the database from somewhere. It's going to apply the changes. It's going to run the unit tests. It's going to report back on the status of the pipeline. And then it's going to destroy the environment if everything's good, or keep it running so the developer can go in there and see what's going on and say, hey, what happened? Here's the log file. Oh, I forgot to do this, or this code isn't compiling. And then the cycle is going to start again. They're going to fix it. They're going to push it into Git. They're going to create a pull request, and it's going to start that process again. Once that pipe is clean, you code review it and you merge it. So let's actually take a look at this running. Creating a pipe in Git is actually or in Jenkins is really, really easy. This is a very short video that shows how to do it. I'm going to create a new pipe. Jenkins directly works with GitHub. There's my username. Here are all my repositories. There's our demo one, and I hit create pipeline, and I'm done. That's going to create a pipeline. I'm going to see a Jenkins file in my repository, and that's where we start building that pipeline from. That Jenkins file is going to be that declarative way, and I use this Blue Ocean Jenkins here to create a declarative pipeline. Very easy to do. So let's actually see a little bit more with a pipeline in action here. So this is a flow that actually has the pipeline that's what we're gonna actually test here. And again, we're gonna push our code. It's gonna be a pull request. The Terraform is gonna create a clone of a particular environment. The environment pre-set up scripts are gonna run. SQLcl is going to apply the database objects. SQLcl is going to apply or install the application express. SQLcl is then going to run the UTP of SQL for the unit test to make sure everything is run correctly, to make sure everything reports back. We're going to look at the pipeline is going to look at the logs for Aura file, Aura errors. You can expand into more, but in this example, we have Aura errors. If it comes back clean, we're going to delete the clone, and then the developer gets notification of the status. It's good. And then we start the whole process of code review. If it's not clean, notification goes out, go fix it. It's going to have, for an autonomous database, maybe we include the wallet and the log files. For a non-autonomous database, we just tell them where it is, and they go and fix it. Again, this is spawned basically because of what we do in the GitHub repository, and we want this to happen on a PR, a merge, or a push. It depends on what you want to do. You can actually configure what it does. So to see this in action real quick, this is an example where I'm just going to update this Jenkins file. And we're using VS Code here because VS Code actually has the ability to move things in and out of Git. Here's a commit. I'm going to save it. There's my commit message on top there. We're just going to call it a commit, and then we're going to push the code. Upon pushing this code into our GitHub, our repository, it's going to spawn a pipe. Now, this particular pipe, what it's going to do is it's going to create an autonomous database using Terraform from a clone, and then using SQLcl, because the Git repository has been pulled over by the pipeline, we're going to apply our changes. We're going to install our Apex app, and we're going to report back. Now, we built this one to actually fail because the user doesn't have the right permissions to create a job. So we'll actually catch that Aura error. But you'll see here that Terraform is going to run. So now Terraform is running, and it's creating the database wallet. We're creating the passwords, and now we're creating that autonomous database really quick. And here, if we just jump into OCI, we'll see that autonomous database pop up really quick. And again, this is an always free autonomous database. So again, there's no charge in using this one. So you can create 2 or 3 always free autonomous databases within your free account with OCI. You don't have to pay for a single thing. Consequently, this Jenkins instance is actually also running on an always free compute in OCI. So it's costing us nothing to use this Jenkins instance here. So it's also running on that micro compute service. Okay, it's done. Now SQLcl has stepped in. It's going to start running things. We see that it's running some scripts to set up the environment, the Apex workspace, just to make sure it's the same. We're going to create some users. And now SQLcl is going to kick in with Liquibase and start creating those objects. It's creating tables. It's creating indexes. It's creating a bunch of packages and procedures here. It's creating some views. It's all doing that right now on this instance here. Triggers. Now it errored out because it tried to create a job, but that's fine because we have an Aura in here. And now we're installing the Application Express app. After this would be done, we'd run our UTP of SQL scripts, and then we would check the log. So here it is. The pipe failed because there's an Aura error in there. And now we just notify it. We're just going to send it to our Gmail account. It failed. Here's the autonomous database zip file to use to get in there. Here's the build log to fix it. Go ahead and fix your code and redo the process. Again, the code for this pipe is going to be in our GitHub repository, so don't worry about creating this yourself. You can see what we did here with that. All right, so how do we deploy to production? So deploying to production, a lot of times what people are doing today is they don't trust the automation quite yet. So what they're doing is they're going to do it manual. They're going to, once Jenkins creates the artifacts, because you can have Jenkins create these artifacts and store them off from you. We have a URL to those artifacts. We're going to just download those artifacts and apply them onto the environment. And that's fine. A lot of people just don't trust that part of the process to deploy it. Now, the good thing about this is you've tested this so many times with the automation, with the pull request, with the merge request, that you know that is a really, really good chance that there are going to be no issues because this has been practiced multiple times on clones of production. So that's that whole CI/CD process of eliminating these surprises because we know exactly how this is going to run on our production environment. So in essence, it should just be unzip the zip, run the file just as we do with the pipeline manually, and then we've deployed into production. Well, if you don't want to do that and you want to automate this so it's automated and does what it needs to do, we can do this. And what I've done here is we have kind of this flow here. that again, once you create that version is checked, comes back clean. We can deploy that version to a pre-test or pre-dev environment to see how it's going to run. And then we can start our deployment pipeline. In our deployment pipeline, we can actually choose where we want to deploy this environment or this code to within the pipeline, and then deploy it directly there. And we can restart this pipeline multiple times to do this. What I found that Jenkins works okay for this, but we took a look at Spinnaker, and Spinnaker actually helps us deploy certain things. So this is a quick environment here. And again, we're just going to create this Jenkins file, and we're going to spawn a pipeline. This pipeline is going to do the exact same thing as we saw. It's going to test the code. It's going to create the autonomous or the database. It's going to apply the code in there. But what it's going to do is that when it's done, it's going to hand the pipe off to Spinnaker. Now, Spinnaker is going to allow us to do some declaratives or to do some decisions where it's going to say, okay, what do you want us to do with this code next? Now, you can have decision points within Jenkins, but we see that Spinnaker actually works a little better, because what we can do is we can spawn separate pipelines based upon a decision. So if we go and look in Spinnaker here, here's our Spinnaker UI, and we've come to a decision point. And in this decision point, it says, where do you want to deploy? Well, I want to deploy it. I have the choice of dev, UAT, or prod. And based upon the choice that I choose here, Spinnaker is actually going to go back into Jenkins and run a specific pipe that we have defined. In this one, we chose development, so it's going to go and run that development pipeline. And we can actually have it look at variables and files within our GitHub repository to make some other decisions. Like, should I even be asking you, or should I just fail the pipeline immediately because you're not ready to deploy? And as we just jump back into Jenkins here, we have this dev deploy pipeline that we do that deploys directly to development environments. It ran and it's successful, and now our deployment or our code is in our development environment. So Spinnaker works really, really well as a traffic cop. Not that you can't do it in Jenkins if you don't want to go to that extra step, but it does give you a nice UI, a nice front end to look at these to look at your deployment pipeline and decide based upon variables as well as human intervention. You may want to make sure that you're ready to go. You may want to save this for a certain time of day to deploy to these environments. Make sure everyone's out. Make sure that the listener's turned off, so you can directly run these things without having any version locks or anything. So that's some little extra credit that we've seen, but it will help you with that process. Okay, oops. Let's go back, and I just shut that. Hang on a second. Let me share PowerPoint here. Oops. Zoom, here we go. All right. So we're almost at the end here. Thanks for sticking along. We'll really talk about rollback. So rollback is an interesting one that we've seen. And with rollback, it depends on what you want to do. So if you have bought off on pluggable databases, you can basically, if there's an issue, roll back the entire database. You could do flashback database, roll back the entire database to a guaranteed restore point that you created before you deployed the code, and you're back to square one, and you can start again. But not everyone is using multi-tenancy. So what we can do is we can roll back the objects via Liquibase, install the last good Apex app, and then we can do a flashback on particular tables, the metadata tables, to restore what they look like before we, if we had a data import as part of the process, we can flash them back to what they look like before we started that process. Or a lot of folks are looking at rolling forward. They fix what happened in production, and then they take those changes and put them back into the main code line. It all depends on what you're doing and how you want to do it. Again, also, if you're using multi-tenancy and doing an application per pluggable database, or if you're still in that non-CDB world and you have a single instance, what you're doing in that instance, because you don't want to roll the entire database back because other applications may be committing data, and you're going to roll all those changes back. So you just have to be cognizant on what environment you're using and how you want to do this. Again, Liquibase does allow you to roll back code, but you're going to have to also look at, implying the older Apex instances and how you're going to roll back some of those metadata changes. So some people are doing rolling forward. or they're just flashing back tables with those metadata changes in there. This is a situation, or this is a scenario that we're going to start looking a little bit more in, because we want to start incorporating things like edition-based redefinition in here, versioning our objects and then switching over the versions. We know the database can do it. But we know we do still have challenges with Apex. Apex does not version at this time. So we are talking to those groups and saying, how can we make Apex versioning a little easier for our developers in this situation? Obviously, it's not going to use edition-based redefinitions, but can we have some way of versioning apps within the builder itself? So this is something that we do have some work on, but we do have solutions today, but we plan on enhancing these as we go forward more and more. Okay, what are the next steps? Where do we go from here? As we talked about, go slow. Don't do everything at the same time. As they say, evolution, not revolution, and all that good stuff. Start with just putting your code in the Git repository and doing everything else as you normally would, and then build upon that. All the code we have here are in a DevOps folder within our Oracle DB Tools GitHub repository. So don't think that because you didn't see exactly how this worked that we're just going to leave you hanging. We're putting all the code in there so you can take a look at how these pipelines are run. We also have a lot of good stuff in there around Terraform and OCI. For example, we just put a Terraform script in there that basically you give that Terraform script a custom domain name, and we'll set up ORDs and your autonomous database and a load balancer to use this custom domain name with an SSL certificate. All you need to do is give it the domain name and then change your CNAME when that load balancer public IP gets spit out, and you're ready to go. It handles everything for you via Terraform and SQLcl scripts. So that's stuff that we have in there, making your life easier as developers. A lot of stuff is in there. And then if you want to see how to do some of this stuff, getting started with OCI, getting started with Autonomous or the Oracle database in general, go ahead over to Live Labs. Live Labs is going to have anything you need in there. And we are committing more and more to that stuff in Live Labs as well. Like our latest one is how to REST enable your database using ORDs. Reach out to us directly. Everyone knows Jeff's Twitter account, Jeff's blog site. We all know that. We all go to that and visit it. So reach out to him or reach out to me. And we also have a Discord group. So we started this Discord group. It's not heavily used, but it is used and we do monitor it. So if you want to drop in, chat, tell us how you're doing, have any questions or what you want to do, let us know. And we can talk to you in that Discord group, give you URLs, give you examples. If you have an enhancement request, something you'd love to see, or if you just want to hang out because we can't go to conferences anymore, it may change at the end of the year, but go ahead and jump into that Discord group. You can ask for an invite. We'll give you an invite and you can use that group and jump in there and again, just talk to us. Myself is in there, Chris is in there sometimes, and Jeff is in there as well. And so, we kind of use that as a conference bar, substitute without the alcohol. So it's a BYOB in there. We can't give you virtual alcohol.
How do they join the Discord group if they want?
The best way to do it is send us a Twitter message, or just hit us on Twitter or send us an email and say, hey, we want to join the Discord group, and we'll send it back to you. We're also monitoring the Oracle chat on Reddit, so you can send us a message there and we'll give you an invite on there as well. So we kind of got a little hung up on time here, but we're going to be doing more of these as we go forward, and more of these as we have more information to share as we start tightening these things up. We plan on adding Liquibase to more things such as SQL Developer Web, having more tighter integrations into repositories. OCI is going to have some stuff going forward as well. So we're going to tighten up this process, but there is a process that we have today with Liquibase and SQLcl that does work. If you run into any issues with this process, again, let us know. We'll help you out. We'll see what's going on, see if it's a bug or not, or help guide you with it. This all will be recorded as well. It'll just be on the Ask Tom site. So you can go on there and take a look at that. Are there any questions that we did not hit here?
Most of the questions were around where can they see the code on this, but you did share.
Yep, that's going to be our GitHub
URL.
Repository, and it's right here. So.
Well, and I will add too, for everybody, you guys can find us pretty easy. We're not hiding anywhere or all over social stuff. If there's something you think we should cover, let us know. We're all about trying to help developers, help everyone do their job better. So if it's a developer-centric topic, no holds barred, we'll cover anything, right? If you guys need it, we'll try and make sure we cover it.
Yeah, we actually have 2 events coming up. Shameless plug. We do have a JSON event coming up, which basically is, Jeff has titled it "Choose Your Own JSON Adventure." So using JSON in the Oracle database in a relational or in a document object method. So that's coming up, I think, April something, 24th, I think. And then we have this Dev Live event coming up, where it's a full day of developer stuff. It's being run 3 times in 3 different time zones. And in that, we have a session on REST enabling and securing REST APIs in your database. So using ORDs to create REST services on tables, as well as business logic, objects, functions, procedures, and then securing them and exposing them out to developers or to different application types. So if it's a REST service, it's no longer Oracle centric. It's a REST service. Anything can consume a REST service. So if you're writing in Xcode, if you're writing in Node.js, if you're writing in Python, if you're writing in whatever, you can now consume securely this data from the database via these REST services. So it pretty much makes the database agnostic to any programming language, because we're just exposing it as JSON and you just consume it. So that also is happening in there as well. Now, we will be, as I said, we are updating this Oracle DB Tools folder as much as possible. And so there's a question on EBR. We are looking at how we can use EBR in this. There's some shortcomings with EBR since it's database whole. When you start versioning things, you can't really do it at a schema level. So we need to, as our product management team needs to run back and talk to their product management team to see if we can shore some of these shortcomings up to get this a little bit more developer friendly. And again, as Chris said, if you have any topics you want to see, or if you want to see anything become easier, let us know. We'll see if we can get that into an enhancement request or writing it up. With that, we are almost a half an hour over. We're 20 minutes over. Thank you, everyone who attended. We have a good portion of people left for hanging out with us for the rest of the time today. And again, this will be recorded. It will be available. And that is pretty much it. Anything, Chris and Jeff, you want to add to this as we close this out?
Thanks everyone for coming. And like I said, no topics are off limits. If you guys want a topic, let us know. We'll wrestle people here. For example, one that we hear is, what is microservices combined with the database? What does that mean, right? In ORDs, we're biased. We like it. We use it, but it's not the only answer out there. So we could do compare contrast for that, for example, or how do I make my JDBC node drivers work the best awesome sauce with autonomous, right? There's many topics, but let us know. Give us some feedback, what you guys think we should cover.
Great. I hear my Discord thing going off, so people are either asking for invites, or my Magic the Gathering group is waking up and asking questions about the latest set that has come out. So it's one of those exciting things for me to go look at. So again, thanks everyone, and we'll talk to you later.
Nice work, Brian. That's a lot of talking.
Thanks, everybody.
I think
the recordings will be up on the website in about a week, I think.
Yeah.
People asking about recordings, they'll be there.